Everyone is talking about RAG, or Retrieval Augmented Generation. So, let's create a RAG using LangChain and Streamlit, and power it using Gemini and Ollama. Large language models are not always to the point, or lack knowledge about a specific topic. In such situations, we will use a RAG or Retrieval Augmented Generation framework to provide an external knowledge base to the LLM. As shown in the image, the model will fetch data from a database and then provide the data and the question to the LLM. The LLM will generate a response based on the provided data. So today we will be creating a RAG with Gemini Pro model and also Dolphin model, which is basically an uncensored fine-tuned version of Mistral model. We will be using Ollama to run this model locally. To install Ollama, simply copy the command from their website and run it in your terminal. I already have it installed, so I won't be running it. Once installed, you can run Ollama list to list all downloaded models. Ollama run model name will download and run the model. Ollama pull model name will only download the model. You can find a list of all available models on their website. The link will be provided in the description. This is the PDF file that we will be using as an external source of information for the model, and it is a PDF on Gemini itself. And here is a text file which will be used too. So we will be able to retrieve information from both PDF and text files. Now, make sure you have your Google API key loaded into a .env file. You can refer to my previous videos to learn how to obtain the API key. Next, we will start importing all the required module. You can install all the required modules by utilizing the requirements.txt file available on my GitHub. Since we are using Streamlit as our frontend, in order to maintain a chat history, we will be using the session storage. We need to create this model type variable in order to handle different models, namely Gemini and Dolphin. Then a simple conditional statement will do the job. Now if model type is set to Gemini, then we will generate response using the Gemini model. Else if the model type is set to Ollama, we will generate response using the Dolphin model, which is running locally. Now, we need to initialize Gemini and provide the API key. We will use the OS module to fetch the API key from the .env file. The persist directory is where we will persist our vector database for future use. For embeddings, we will be using the Embedding 001 model by Google. Now we will check if the persist directory exists. If yes, then we will load the vector database, else we need to process the documents and create our vector database. We will be using the directory loader to load the files from a directory with a specific file extension, which in this case will be .pdf and .text. As the name suggests, the splitter is responsible for splitting data into chunks. Next, we need to extract data from every page of the document, and this is how we will be doing it. Data from every page is separated by two new line character. Then, we will split the data into chunks. The splitter will return a list of chunks. Then we will combine the chunks from PDF files and text documents to get our required data. For the vector database, we will be using ChromaDB. The query chain is responsible for retrieving data from the language model. Since we want a chat conversation, we will be using the chat message function from Streamlit. This is how we will display all the messages in the chat history. We will use the chat input function from Streamlit to obtain user input. We need to update the message history stored in the session every time the user asks a question or the model generates a response. We will employ a spinner during the time when the model is generating a response. The spinner function will be utilized for this purpose. Now, before we run the application, I want to show that the Dolphin model is having no information about the Gemini Nano model. As you can see, when I ask about Gemini Nano, the response is all about a digital camera, which has nothing to do with Gemini large language model. So, let's run Streamlit. Depending on the number of documents and the size of documents, the first run may take a while. And you might see some errors in the Streamlit app too. This is because of Streamlit's nature. Once you see the message vector DB creation complete in the terminal, just reload the Streamlit app and everything will work just fine. This will only happen with extremely large data. Now, as you can observe, if I inquire about anything outside the provided data, the model will not be able to provide an answer. Let's ask the model about Gemini Nano and observe its response. And as you can see, the model does have a response on Gemini Nano. Now, let's use the Dolphin model. We simply need to change the model type to Ollama and rerun the app. Let's question the Dolphin model about Gemini Nano. As demonstrated earlier, the Dolphin model lacks information about Gemini Nano. This will serve as a good test for our RAG. Depending on your system, it may take a while to generate a response. And, as you can see this time, the Dolphin model was able to provide information about Gemini Nano model. Thank you for watching. Don't forget to like, share and subscribe.